Ever wonder how your phone's voice assistant sounds so smooth? Or how audiobooks can mimic real human voices? It's all thanks to text-to-speech, TTS, technology, but there's a sneaky challenge hiding in plain sight. Let's unravel the mystery behind the timing of AI voices, and how a new breakthrough is making them sound more human than ever. So TTS systems take written words and turn them into speech. But here's the catch: timing. How long should each word be? How do you make the voice feel like a real person, not a robot? For years, researchers could tweak the sound of the voice, but one piece kept tripping them up: the duration predictor. Think of it as the AI's internal clock. If it's off, the speech feels stilted or unnatural. Enter DMOSpeech 2, a game changer that finally cracks the timing code. How? By using reinforcement learning, a type of AI training where the system learns by trial and error, like a dog learning tricks with treats. Instead of guessing word lengths, DMOSpeech 2 optimizes them in real time, balancing accuracy, naturalness, and speaker likeness. Here's where it gets clever. The team used a technique called Group Relative Policy Optimization, GRPO. Imagine training a DJ to mix music by giving points for beats that flow smoothly, not just for technical accuracy. DMOSpeech 2 compares different timing strategies and rewards the ones that sound most natural. It's like teaching a robot to speak with rhythm, not just words. But there's another hurdle: speed. When models generate speech faster, they often lose the rich variation in pitch, pace, and emotion, what we call prosody. This is called mode shrinkage, where everything sounds the same. To fix this, the researchers added teacher-guided sampling, a hybrid approach where an expert AI, the teacher, handles the tricky early steps, like setting tone and rhythm, while a faster student model takes over for the rest. It's like having a master chef guide a trainee through the hardest parts, then letting them finish the dish. At the heart of DMOSpeech 2 is a clever system of critics and creators. Think of it like a game. One part of the model, called the discriminator, acts as a judge. It analyzes speech generated by another part, the generator, and gives feedback. But here's the twist: the discriminator isn't just looking at raw sound. It takes in clues like the text the speech is supposed to match, how much noise was in the original signal, and even the flow of the generation process. This helps it spot when the AI is faking it. The model uses two types of feedback loops. One rewards the generator for making speech that fools the discriminator, while the other punishes it for failing. These are called adversarial losses, like a teacher grading a student's work. The math behind it is complex, but the idea is simple. The generator learns to improve by constantly adapting to the discriminator's critiques. But DMOSpeech 2 doesn't stop there. It directly targets two key goals: making speech sound like the original voice and ensuring it's easy to understand. For voice similarity, it uses a speaker verification system. Think of it as a voice print matcher. For clarity, it integrates a connectionist temporal classification, CTC, loss, which aligns generated speech with text to reduce errors. Training this model is like juggling multiple priorities. The system balances four types of losses, errors to minimize: one for basic speech quality, one for fooling the discriminator, one for voice similarity, and one for accuracy. To keep things stable, the model starts by mastering basics before fine-tuning details, like learning to walk before running. DMOSpeech 2 also relies on a few key tools. A vocoder converts abstract sound patterns into real audio, while pre-trained models for speech recognition and voice verification act as quality checks. These tools are like a chef's kitchen, essential for turning raw ingredients into a gourmet dish. The final test: human listeners. In experiments, participants compared DMOSpeech 2's output to other systems, picking which sounded more natural or closer to the original voice. The results: the model outperformed competitors, proving its ability to balance quality, clarity, and realism. So what's next? As AI gets better at mimicking human speech, we're not just hearing voices, we're feeling them. Thanks for watching. If you want to dive deeper into the science behind AI voices, hit subscribe. And drop a comment below. What's one thing you'd love to hear an AI say? Let's keep the conversation going.